Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I welcome you for the first lecture for the 9th class regarding the chemistry. Today we have selected the formula, stoichiometry and the mole concept. This topic is from your chapter number 5 from the book and the topic number 3 from CIE syllabus. I have finalized some objectives for you for today. These objectives are as follows. The number one objective is the symbols of the elements and the formula of the compounds. We will understand the symbols and the formula of the compounds today. The second is the formula of simple compounds from the relative number of atoms present in a compound. And the third objective for today's lecture is the formula of ionic compounds from the charges on the ions present. First of all, we are going to study the symbols of the elements or atomic symbols. What are these and what are the importance of these symbols? The atomic symbols are a shorthand way of representing an element or an atom of an element. It is usually denoted by the initial capital letter. For example, the symbol for carbon is C. So all the elements in the periodic table are represented by the abbreviations of their names so that we can easily understand and write it. But if sometimes two or more elements starting with the same letter, then the second or third letter written in the same form is added with the first capital letter. Here are a few examples so that you can understand how we can write the names of the elements which are having the same first letter. For example, the calcium, carbon, cesium and chromium, and some other examples are as well written on this slide. Calcium, carbon, cesium, chromium are started with the letter C. So first letter is capital, but the second letter is small so that we can understand all the elements. If all these elements are written with only C, so it is not possible to understand. So we have added another letter in the small form so that we can understand different elements with the same symbol, first letter. For example, the calcium Ca, carbon only C, cesium Cs, chromium Cr. So from this we can understand that the elements are represented by their abbreviations of their names so that we can write it and understand them easily. Dear students, now we are moving towards the next, and next is the formula of the compounds or molecules. As we have studied the symbols of elements, when these symbols of different elements we write together, this becomes the formula of the compounds. The formula basically is an abbreviated expression of a chemical compound or molecule. Abbreviated expression, just like the symbol of elements. But it also tells us a proper combination of chemical symbols. It means that how many atoms are there and what is the percentage of these elements in that compound. To understand this, I have selected an example of water molecule for you. We can see here the formula of water, H2O. You can see that the water is made up of two types of elements. One is hydrogen and second is oxygen. But this chemical formula of water is also telling us the number of atoms of hydrogen and the number of atoms of oxygen. You can see that H2O means that water is made up of 2 atoms of hydrogen and 1 atom of oxygen. Here are a few other examples for you. The first example is salt. This is a common salt which we use in our homes. The name is sodium chloride, and this is the chemical formula NaCl. Na represent the sodium and Cl represent the chlorine. This chemical formula of common salt is telling us that the sodium chloride is made up of two elements, and these elements are having only one atoms, Na1 and Cl1. And the second example in this slide is of sucrose. Sucrose is an organic compound, and this is made up of three types of elements: carbon, hydrogen and oxygen. And this formula of sucrose is also telling us that carbon is having 12 atoms, hydrogen is having 22, and oxygen is having 11 atoms. So another example which I mentioned in this slide of vinegar or acetic acid, baking soda or sodium bicarbonate. You can understand that the chemical formula of any compound or molecule give us the types of elements in that compound and the number of atoms of these elements in a particular compound. Dear students, now we are moving towards the formula of ionic compounds. Now we have understand what is formula and what is the importance of formula. Now we are going to focus on the ionic compounds. What are ionic compounds? The compounds which are made up of ions. And you know that ions are formed when atoms give up or take up the electrons. Here are few examples of ionic compounds. The first example is calcium chloride. Calcium chloride is made up of two types of ions. One is cations and second is anion. Ca plus 2 is a cation. This is a positive ion, and Cl minus is a chloride ion, this is a negative ion. This formula of Cl2 calcium chloride is telling us that calcium chloride is made up of two types of elements. One is calcium, second is chlorine, and the number of calcium atom is 1 and number of chlorine atom is 2. This ionic compound is also telling us that how many ions are present, charges are present on the ions. In calcium chloride, Ca is having plus 2 charge and chloride is having minus 1 charge. And the second example is barium oxide. This barium oxide formula is also telling us that the barium oxide is made up of two types of elements, barium and oxygen. Barium is having plus 2 charge and oxide is having minus 2 charge. And the number of ions are same. Barium is 1, oxygen is 1. But the charges are plus 2 on barium and minus 2 on oxygen. So in this way, from ionic compounds, we can understand the types of atoms, their numbers, and the charges present on these ions, which are going to make the ionic compounds. Here are a few other examples: potassium sulfide, ferric bromide, and chromium oxide. You can study them so that you can understand the types of atoms and the number of atoms present in these compounds. Now we are moving towards the next slide, and that is the equations. What are equations? Equations describes what happens during a chemical reaction. What is chemical reaction? Chemical reactions are those reactions in which the different compounds react with each other and forms the new compounds. The reacting compounds are called reactants, and the new compounds which are formed, they are called products. So chemical equation describe what happens during a chemical reaction. For example, iron combines with sulfur and form iron sulfide. So this conversion of iron and sulfur into a new compound, iron sulfide, this is called a chemical reaction, and its representation is called a chemical equation. Here is an example which is given on this slide, that equations, how our equations can be represented. Number one is a molecular equation in which the lead nitrate combines with the potassium chloride and forms a new compounds, lead chloride and potassium nitrate. This conversion of reactants into products is represented by an equation. This equation can be elaborated by ionic equation. The second equation is representing the ionic changes, the changes which are leading towards the formations of new products. For example, the lead combines with chlorine or chloride ions and forms a lead chloride, and the potassium attaches with the nitrates and form the potassium nitrate. This conversion is called chemical reaction, and this representation of a chemical reaction is called equation. Dear students, you have understand the role of equations. Now we are moving towards the very important point, and that point is empirical formula. What is empirical formula and how it can be written? The empirical formula is the lowest whole number ratios of atoms in a compound. The simplest whole number ratio of atoms in a compound. This is the simplest form to write any chemical formula. This is the simplest way to write the chemical formula of any compound. But all the chemical formulas of compounds cannot be simplified. Here are a few examples from which you can understand how the chemical formulas can be converted into empirical formulas. For example, the first example is benzene. Benzene, this is having formula C6H6. We can convert this chemical formula of benzene into empirical formula. The empirical formula for benzene is CH. A ratio of 6/6 is equal to 1/1. Because both the carbon and the hydrogen are having 6 carbon, so we can simply represent it by CH, and the whole number is 6. The second example is acetic acid. Acetic acid formula is C2H4O2, and the empirical formula for this acetic acid formula is CH2O. A ratio of 2:4 is equal to 1, 2 and 1. So we can write the acetic acid formula C2H4O2 as CH2O. And the third example is of propane. The formula for propane is C3H8. But the empirical formula cannot be simplified, so we cannot have empirical formula. Or we can say the propane empirical and chemical formula is same, because the ratio is of 3/8 on both sides. So we cannot convert this propane into a simplest number. So empirical formula for propane is the same as the molecular formula. So you understand now what is empirical formula and how it can be written. Now we are moving towards the next very important topic, and that is the percentage composition. What do you mean by percentage of composition? Percentage composition means the percentage of any element in any compound. We can determine the percentage of any element or all the elements present in a compound. What we have to do, the part of that element divided by a whole number and multiply by 100 is equal to the percentage of that particular element in a compound. For elements we can understand in this way: mass of element, molecular mass, divided by molar mass multiplied by 100 is equal to the percent of the element. Here are few examples which can help you to understand these percentage, how to calculate the percentage in a compound. The molecular formula for ethanol is C2H5OH. The molar mass of ethanol is 2 into 12.01 plus 6 into 1.008 plus 16. The two molar mass for two number of atoms of carbon, and 12 is the molar mass of the carbon. 6 is the number of hydrogen atoms in this ethanol and multiply by the molar mass of hydrogen, and 16 is the molar mass of oxygen. We are not going to multiply it with 1 because oxygen is atom of oxygen in this molecule or compound is 1. So we are going to find the mass percentage of carbon first. The carbon mass is 12, but the atoms of carbon in this compound are 2, so 12 multiplied by 2 is equal to 24, divided by the total mass of this compound, ethanol. The total molar mass of ethanol is 46.068. So 24.02 divided by 46.068 multiplied by 100 is equal to 52.14%. So in this way we can find out the percentage of carbon in ethanol. And now we are moving towards it to find the percentage of hydrogen in ethanol. The number of hydrogen atoms are 6 and the molar mass of hydrogen is 1.008. So the molar mass of total number of hydrogen in this compound is 6.048 divided by the molar mass of ethanol, which is 46.068, multiplied by 100, and the answer is 13.13. So we can say that the hydrogen percentage in ethanol is 13.13. The mass percentage of oxygen is having 1 atom and the molar mass is 16. So 16 divided by the molar mass of ethanol, which is 46.068, multiplied by 100, and the answer is 34.73%. So we can evaluate the percentage of oxygen in ethanol, which is 34.73%. In this how we can find out the percentage of any element in the compound.